Okay, Unit 1, Lesson 11, Day 2. So we're doing a little bit more on absolute value equations today. So yesterday, you found out the basics of how do I solve equations that have this absolute value in them. Today, we're going to take that same concept and just make sure that you can solve a little bit more complex equations using that same process and the same idea. So we're going to make sure that we can solve those and find the possible solutions, and then just check to make sure our solution works, and also watch out for those no solution problems as well. All right, so to get us warmed up and ready, we're going to link up to yesterday's work a little bit. So this warm-up says, show that the solutions -8 and 2 work with the equation on a number line. All right, so go ahead and pause your video and see what you can do with that warm-up. All right, so yesterday we kind of learned what it meant for the absolute value to be that number of units away from 0. So in this case, whatever I get inside my absolute value has to be 5 units away from 0, right? So what I'm going to do first, I'm going to take this -8 and I'm going to plug it in for x. So I would have the absolute value of -8 plus 3 is supposed to equal 5. Now, since I have a number in here for x, I can actually do this simplifying. So that would mean that I would have the absolute value of -5 is supposed to equal 5. So that means that -5 is supposed to be 5 units away from 0. And -5 would be over here, and it absolutely is 5 units away from 0. So that answer does work. So then the other thing I'm going to do is I'm going to take this 2 and I'm going to plug it in for x. So now I'd have the absolute value of 2 plus 3 is supposed to equal 5. So again, since I have a number in here now, I can actually do this simplifying. 2 plus 3 is 5. So I have the absolute value of 5 is supposed to equal 5. So on a number line, that's telling me that 5 is supposed to be 5 units away from 0. And that is absolutely correct. So just remembering that absolute value means that it's supposed to be that number of units away from 0. All right, good warm-up to get us prepped. So that whole process was part of what we did yesterday. What we're going to do today now is just remember, how do I actually do the solving to find those values, right? That was our mental process for checking to make sure they worked. But today, how do I actually find those values? And so we're going to really go through and make sure that we understand, how do we separate into our two different equations? How do we make sure that absolute value is by itself first? And then don't forget to check for those no solutions. So our first example here links exactly back to what we did yesterday. This was one of the more complex ones that we did yesterday. But if you remember, what this is saying is the absolute value of 2x minus 7 has to equal 3, which means that whatever this ends up being, after I solve for x, when I plug it back in, whatever that number ends up being has to be 3 units away from 0. Right? So whatever that 2x minus 7 ends up to equal, it could be 3 units to the right of 0. So I could have one possibility where 2x minus 7 equals positive 3, because that would mean that it would be 3 units to the right of 0. But the other possibility is if whatever that equals is 3 units to the left of 0. So my second possibility is that 2x minus 7 equals -3. So remember, we have to set up those two different equations. I don't change anything inside the absolute value because I don't know anything of what that is. That has to stay exactly how it is. But what I do know is that whatever that is has to be 3 units away from 0. So it could be 3 units to the right, or it could be 3 units to the left. And that's where those two equations come from. So now I just have to actually solve each of my equations. So I have 2x equals 10. I divide both sides by 2, so I get x equals 5 as one of my possibilities. And then I go and I solve my second one, so I add 7 to both sides on this one, so I get 2x equals 4. And I divide both sides by 2. And I get x equals 2 as my second possibility. And now I can just go and do some mental math here, right? If I plug in positive 5, 2 times 5 is 10. 10 minus 7 gives me positive 3. That is 3 units away from 0. If I plug in my positive 2, 2 times 2 is 4. 4 minus 7 is negative 3, and negative 3 is also 3 units away from 0. So there's the idea of splitting it into those two equations just like we did yesterday and checking our work. All right, now here's one that looks a little bit different. So this time I have the absolute value of v minus 4 plus 1 equals 3. So when I look at this original equation, just how it is, I don't know what that distance away from 0 is supposed to be because I've got more going on the same side of the absolute value. So I'm not sure what to set my equation equal to. And this is exactly why our first step, whenever I'm solving these absolute value equations, needs to be to get that absolute value by itself. Get the absolute value alone first before you split into two separate equations, because you don't know what that distance is supposed to equal until your absolute value is all alone on that side of the equal sign. So my first step has to be to move that 1. So when I subtract a 1 from both sides, I get the absolute value of v minus 4 equals 2. All right, well now I know when I'm looking for the distance away from 0, this v minus 4, this inside that I'm not changing, well, that could be 2 units to the right of 0, right? So I could have v minus 4 equals positive 2. The other possibility is that inside the absolute value could be 2 units to the left of 0. So I have v minus 4 equals negative 2. And those are the two possibilities for what that inside that absolute value could equal for the distance to be 2 units away from 0. So then I just go through and I solve each one. So if I add 4 to both sides over here, I get v equals 6. And if I add 4 to both sides on this one, I get v equals 2. So positive 6 and positive 2 are my two solutions. Now I definitely could go back in and check. This mental math is going to get a little trickier. If I plug in positive 6, 6 minus 4 is 2. The absolute value of 2 is 2. When I add 1, I do equal 3. If I plug in positive 2, 2 minus 4 is negative 2. The absolute value of negative 2 is 2. 2 plus 1 does equal 3, so it does still work. So these are going to start to get a little bit more difficult to do in your head. You could write them down if you really want to make sure to check your answers, or you can really keep track of your mental math if you want to. Okay, so here's another one also similar to that one, right? I don't know what that distance is supposed to be yet. I have absolute value of x plus 2 minus 4 equals negative 4. So I don't know what the distance is supposed to be until I isolate that absolute value. So my first step needs to be to move the 4. So I'm going to add 4 to both sides. So I get x plus 2, the absolute value of x plus 2 equals, negative 4 plus 4 is 0. Interesting. So here, this is saying that the distance, whatever I get inside this absolute value, the distance that is away from 0 is 0 units. So inside that absolute value has to be 0 units away from 0. Well, there's only one way for that to work, right? Is if x plus 2 actually equals 0. So this is the very rare possibility that I end up with only one solution, because there's no such thing as negative 0 units and positive 0 units. It's just 0 units away from 0. So if I actually do this solving to figure out what x is going to equal, I'll get x equals negative 2 as my only solution. Now if I plug that in, negative 2 plus 2 would give me 0. So absolute value of 0 is just 0. So then I end up with negative 4 equals negative 4, and my equation does work. So be careful. There is a very rare possibility when that absolute value equals 0, there's only one solution there. But it is very rare. Almost always you will have two solutions for these. All right, our last one here, we've kicked it up as much as we can. This is just a way to make sure that you know how to get that absolute value all by itself, no matter what we throw at you. So again, I can't split it into two equations until I isolate that absolute value. So my first job is to get rid of all the numbers outside the absolute value. Now when I read through this equation, I see that it says 2 times the absolute value of 2r minus 8, right? When I have that number written right next to the absolute value symbol, it's just like a number right outside parentheses. It means times. The only thing is you cannot distribute into an absolute value. No way. You have to get rid of that 2 at some point, okay? So just be careful. No distributing into an absolute value. So I have 2 times the absolute value of 2r minus 8, minus 1 on the outside equals 39. Now this 2 times is real tight to that absolute value. The minus 1 is kind of looser. And if I do the operations in inverse order, right, like we were supposed to do in solving, then I would have to move the 1 first. I like to think of it as getting rid of the loose guys. We got to move the loose guys before we move the tight guys. So the first thing I'm going to do is I'm going to add 1 to both sides. So I still have my 2 times the absolute value of 2r minus 8 equals 40. All right. Now again, I cannot distribute that 2 into an absolute value, can never do that. But I wrote that time sign there to help trigger my brain to realize this is 2 times the absolute value. So if I want to get rid of that 2, I need to divide both sides by 2. And that will get rid of that 2 in front. So I'll have the absolute value of 2r minus 8 equals 20. All right, so now I can tell, I have my absolute value by itself, so I can tell that I need to be, one possibility is for it to be 20 units to the right of 0, to be 20 units away. So I could have 2r minus 8 equals positive 20. My other possibility is that I'm 20 units to the left of 0. So I could have 2r minus 8 equals negative 20. All right, so I had to isolate that absolute value before I split it into 2, but once I get there, then I leave that inside alone, and I say, well, that could either be 20 units to the right or 20 units to the left, and that's where my 2 equations come from. And now I just solve each one. So I'm going to add 8 to both sides over here. I get 2r equals 28. And then I am going to, here we go, divide both sides by 2. So I get r equals 14. So one possibility is that r equals 14. Okay, second possibility over here is I'm going to add 8 to both sides on this side. So I get 2r equals negative 12. And then I divide both sides by 2. And I get r equals negative 6. So I have positive 14 and negative 6. And if I go back and plug those in, they will both work. It'd be a lot of mental math at this point, so you could write it down and double check, but those ones should work. So the idea with this one is just make sure that you're moving every number on the outside of the absolute value away before you split it into your 2 equations. And remember to do your order of operations in opposite order. Get rid of those loose guys first, add or subtract, and then multiply or divide to get that absolute value by itself. All right. So just some hot tips here. Remember to stay organized with your work. After you isolate the absolute values, split it into 2 equations and then solve each one. Most absolute value equations have 2 answers, so just make sure that you set up those 2 equations before you start to solve them. And then watch for those no solution problems, okay? Remember, absolute value can never equal a negative number because we can't be a negative distance from 0. All right, it's your turn to practice. You can do it.